Okay, we'll talk about a couple of we'll see, a couple of concepts called reliability and validity. And you've encountered these terms probably in a couple of other courses. Let me kind of tie them down to the context that we're talking about here. Validity, I'll deal with these separately, but let me kind of start off together. Validity has to do with whether or not an instrument measures what it's supposed to measure. Have you ever gone into an English class and they gave you a calculus test? It might be a perfectly good calculus test, but it doesn't measure what you expect to be measured in an English class. So that would not be a valid way to measure your English ability or understanding or learning. Does this test measure your ability to understand grammar? If that's what it's supposed to do, and that's what it does, it's a valid instrument. It's pretty important we measure what we're trying to measure. Now, there are different kinds of validity. I'm going to get into a couple of different kinds of validity in just a minute, but for right now, validity does what it's supposed to do. It measures what it's supposed to measure. Reliability has to do with whether or not an instrument measures consistently. That means if you give it the same circumstance, it gives you the same results every time. Can an instrument be reliable but not valid? And the answer is, yeah, a lot. Well, which is more important, validity or reliability? Is it consistent or does what it's supposed to do? It's not a trick question this time. Validity is more important because if it measures what it's supposed to measure, you can't do that inconsistently. So if an instrument is valid, it has to be reliable. However, we can have instruments that are reliable, but they're not valid. And I'll give you a couple examples in a minute. So the math teacher in me wants to do this. Here are all the things that are reliable. Here are all the things that are valid. If you're valid, you're reliable. If you're reliable, you may or may not be valid. Here's an example of something that's reliable but not necessarily valid, but it can be very useful. You're going to drive home tonight if you're in some place other than home. If you're here, you're driving home. If you're at a library or school watching the video or whatever, you're going to drive home later. You're going to drive somewhere soon, probably. How do you know how fast you're going? You look at the speedometer, which hopefully tells you how fast you're going. Ever have a car that the speedometer's a little bit off? Yep, probably pretty much every car you've ever had the speedometer's off a little bit. So that speedometer doesn't really tell you true speed, but it hopefully gets pretty close. What the speedometer can do, it can tell you when you speed up 5 miles per hour or whether you slow down 5 miles per hour. It's useful. If you're going at the certain speed, the speedometer is going to register the same thing every time. That's reliable. That's consistently. A bathroom scale is another instrument that's reliable but not consistent. Your scale may be off a little bit. It's still going to tell you if you gain or lose 5 pounds. If you step on it, get back off, step on it again, it's going to give you the same measure. So it's not valid because it's not, in this context, sort of a synonym for validity is accurate. I have a little bit of, and we've used the word accurate before in the context of the last couple of courses, this course and the statistics course that you took before this one. And I've made this statement, this is a good time to make it again. Pretty much any time you measure something, the results are not accurate, but hopefully they're kind of close. They're in the ballpark. And the more you measure something, or the more ways you measure it also, the more likely you are to be close to what is the truth. Remember our discussion about confidence intervals. This is why you don't just give one test and assign a whole course grade on it. You take different measurements, different ways, and hopefully that helps you kind of zero in on it. So yes, validity is the most important, or the more important of the two. Guess which one is easier to determine? It ain't the one that you'd want it to be. It's easier to determine if an instrument is reliable or not. So reliability has to do with consistency. Validity has to do with whether or not something measures the way it's supposed to measure. Let's put this into some context. Let's look at some specific examples. First, let's talk about reliability a little bit first. And I will tell you, there's some fuzziness here. Reliability is a good thing. It's not the best thing, but it's a good thing. So when we look at these real short kind of situational descriptions, just think whether is it a good thing to do this or is it not a good thing to do this. And I'll tell you, there are a couple of it depends on here, because life is full of it depends. Number one, is it reliable or not reliable to do this? Mrs. Stallings decides to base the spelling test grades on a 100-item test rather than on her previous 10-item test. Is it reliable to make the test longer to have more items? I see heads shaking both ways at the same time. Yes, that is reliable to do that. It's it is like, you get better data with a larger N. You're going to be able to measure spelling ability. Yeah, and I'll make that point in a minute too. In general, more is better. However, what was just pointed out, that there's kind of a point where it becomes an exercise in endurance, and that's not what you're trying to measure. So more is better, but at some point, your rear end starts to hurt because you're sitting there answering this long test, and it kind of the quality of your answer sort of just kind of goes down the tube. What if my spelling ability is actually 83? I can't get 83 on a 10-item test. 100-item test I could get there. But you're right, that's a long test. So you have to weigh the pros and the cons. Shorter is easier. It doesn't have the fatigue factor, but it doesn't give you very detailed information sometimes. It's better to collect information from 100 people than it is from 10 people. It's the same principle here. Number two, Mr. Carroll is proud of his 10-item test because it contains 5 mind benders that nobody can get. I'll show you. I'll just ask you something that's impossible to answer. Is it reliable to have those unanswerable questions? Let me make a statement, and you can rethink what it. Well, maybe you want to rethink it, or maybe you don't. Greater variability is more reliability. If I'm asking 10 items and nobody's getting 5 of them, I'm really only measuring things on 5 scale, 5 different things. That's not very reliable. If something is if it's a test, if it's either too hard or too easy, it's not reliable. That takes away from the reliability. Number 3, we give a 50-item test every 2 weeks. Used to, we would give tests on a common set of objectives, but now we're going to save time and just test on 5 different objectives on the same 50-item test. This is a little bit similar to the number 1 situation. Instead of measuring something with 50 items, we're going to measure a bunch of things with 50 items. Hey, that's efficient, right? But if I have 5 different objectives, that means I'm only going to be using 10 items to measure each objective rather than 50 items to measure an objective. Probably not reliable. Again, we're cutting down on the number of things we measure about a particular objective in this case. And I know I'm doing these quick. Yeah, we all know teachers like this. I have to admit, in some of these cases, I've been the teacher, kind of like that. I have to confess. 4. We're measuring creativity by giving a student a highly imaginative problem and saying, solve it. That's not reliable for a couple of reasons. One is that we're just giving one thing to do. But the other thing is, let's say, okay, I'm an English teacher. I'm teaching Tom Sawyer. I want you to demonstrate your understanding of part of Tom Sawyer by drawing a picture of him having his friends whitewash the fence. It's creative, it's imaginative. I can't draw worth squat, so I'm not going to be able to show what I really understand about it. So what you're measuring and the way you're measuring don't go together in this case. It's not reliable to do that. I'm going to skip 5. We were going to give a test on Friday, but we changed it because I heard the biggest pep rally of the year is going to be right before that class. Is it good to change it or not? Probably so. Yeah, you're probably going to get more reliable information if there isn't this kind of distraction. Now, you can't eliminate distractions. All you can do is minimize them. Because there's going to be some distraction, whether it's the pep rally right before or whatever. But that's one we should probably try to avoid. Now, the downside of this, too, is putting it off at least over the weekend. You know, that may be problematic. So there's a little bit of fuzziness even here. Yeah, all things being equal, it's best to avoid the pep rally, but you're also trading off some other things. Number 7, Ms. Wolf likes to promote informality with her students because she feels it makes them work to the best of their ability. So she's going to set aside the instructions for the standardized test and just explain in her own words. It's a noble motive, but is it a good thing to do or not? And it's not a good thing to do. Because for a couple of reasons. One is that part of what's standardized about a standardized, yeah, I know. Well, you're exactly right. Yeah, I couldn't do that with my ACT friends. You know, part of what's standardized about the test is that you hear the same instructions, except around here you hear them without the accent. And I've administered a lot of these kinds of tests too, and everyone I've admitted, there's always a place where I say, are there any questions? And I can answer questions however I want to answer them. But I can't just say, well, I'm going to paraphrase the instructions this way. Otherwise, the difference in test scores from one person to the next might be because they heard instructions differently. So you can't do that. Now, you can add to it, but you can't replace it. Last one, there's a wide range of skills in Mr. Johnson's Spanish class. Most items were answered correctly by 60 to 90% of the students. And I'll go back to a statement I made a little bit earlier that the more variability is more reliability. And since this is defined as a wide range, then yes, this would indicate reliability. If everybody made the same grade, that's not very reliable. If I gave you a test that was just so easy, everybody made 100 on it, that's not a reliable measure. It doesn't tell me anything. So again, too easy or too hard works against reliability. There's the, as I so scholarly say it, there's a fair amount of spread outedness, and that would be indicative of reliability. I want to go through just a couple examples of validity real quick, and then we'll see if we need to, or how much more we need to say about it. Let's look, and again, I think you have this on D2L2. It's called Validity Worksheet. I said that we'd talk about different kinds of validity. I didn't say much about ways of determining or measuring reliability, but we'll talk a little bit about that in terms of validity. Just kind of as a general statement, to determine, one way of determining reliability and consistency is if there is a significant positive correlation between two things, that would indicate consistency. You ever taken a survey where you feel like you've answered the same question more than once? And the answer is you have. And the reason they do that is to see if you answer consistently. And consistency is reliability. One way of determining, I said I wasn't going to talk about it much, and I'm not, but I'll say this. Let's say I have a 100-item test, and I might have the even items covering all the material, and the odd items covering all the material also. If there's a high correlation between the way you answer the even ones and the odd ones, that indicates consistency and reliability. A lot of times you will see reliability indexes indicated by R, because a lot of times it's based on correlations. Now, different kinds of validity, and there's a lot of similarities with what we just said too. The kinds of validity I want to talk about here, and these are not the only ways we can do this, but content validity, keeping in mind that validity means you're measuring what you're trying to measure, means if it really measures the content. Well, duh. Predictive validity means if it predicts something with some degree of reasonable accuracy. Concurrent validity, concurrent means at the same time or along the same way. Concurrent means it does something similar to something else. And then we've got examples of these. Construct validity means we're actually measuring the construct. So I've got at least one example for all these. And one of them is going to be used twice. Number one, the test designer has developed an anxiety measurement scale and wants to verify that it measures a characteristic labeled anxiety. Well, what is anxiety in terms of all the words in front of us right now? Anxiety is a construct. So does it measure that construct? You can't directly see anxiety. You can see what it looks like. You can see behaviors that are indicative of anxiety. Those are directly observable, but you can't see anxiety itself. You can see what it makes happen. So can we measure anxiety? If so, we're looking for construct validity. If you're watching this on recording, you may want to hit pause and think about these things before I just say them, even if you're going back over it. Number two, the counselor wants to select students into his school's college prep program based on the likelihood they'll succeed in college. I want to know whether certain tests can help accomplish this process. What is he trying to do? I want students who are going to succeed in college. I want to tell if you're going to be able to succeed in college or to some likely degree. So I'm trying to predict. So I want this to have predictive reliability. Let me flesh out this kind of example just a little bit more too. For example, we use the ACT. Since we're talking about ACT, I'll bring that up in this context as well. We use the ACT as a college entrance factor. Does the ACT predict college success? And the answer is yeah, to some degree. What statistic would we use to tell if people who score well in the ACT tend to do well in college? And I kind of left that open intentionally, how you define that. Let's say I'm going to operationalize college success by GPA. Your GPA is going to tell, which is a bad way to do it, I know, but it works well for this example. If I can correlate ACT and college GPA and get a significantly positive correlation, that would indicate predictive validity. I could do some other things too. I could say I'm going to have a bunch of people, I'm going to put them into two groups, whether they were successful in college, whether they're not, and measure the ACTs of those successful people with, say, an independent t-test against the ACTs of the not successful people. There's a couple ways you can do it statistically. See if there's a significant difference that way. Number 3, and this is probably the fuzziest one. A test designer has developed a new 10-minute IQ test. And I want to show that this does about the same thing as the Stanford Binet test does. The Stanford Binet is an instrument that has accepted and established validity. So if it's valid, and mine does the same thing that does, then mine must be valid too. That's concurrent validity. And you could probably determine that by correlation as well. Number 4, want to make sure that all the exams in the English composition courses cover the objectives they're supposed to cover. That's probably the most straightforward one. What are we trying to determine here? Somebody type in, make sure I know some of y'all are still alive out there. What kind of validity does number 4 have to do with? What is it we're measuring? Or what is it we're trying to do? There you go. Yeah, we're trying to make sure that we're actually measuring the content, understanding of the content. That's content validity. We're measuring ability in English or understanding in English. We want to see if our test does that. Lastly, we want to find out if the students who fail the teacher's final comprehensive exams are the ones who are going to have trouble with similar materials next year. Think of the time on this one. If this happens now, is that going to happen then? So what are we looking to do? We're looking to predict. So we're wanting to see if this has predictive validity. Again, all these types of validity, and other types as well, there are other ways you can classify different kinds of validity, but they all have to do with, do they do what they're supposed to do? If they're supposed to predict, do they predict? If they're supposed to measure understanding of content, does it measure understanding of content and so forth? So validity is, does it do what it's supposed to do? Reliability, does it do what it does consistently? Other questions, thoughts, comments on, that's just a quick and dirty overview of validity and reliability. Okay.